Often with independents, they ask them with contingency tables or two-way tables. So a question like the following. The following table identifies a group of girls by hair color and whether their hair is tied up or not. So I've got brown, blonde, black, red, and I've got not tied up, tied up. And there are all sorts of holes in it. This is again another nice level 2 question, because the first question is redraw and complete the table above. So it's basically 20 plus 80, 100. What plus 15 is 20. And so you get all the bits and pieces, working out various bits before you can get, to determine which ones you've got to get first and so on. But it's not a bad question. And then what is the probability that a randomly selected girl will have their hair not tied up, brown hair not tied up, either brown or blonde hair? And then from the girls whose hair is tied up, determine the probability that they have black hair. Now, I would do this with grade 10 because it should be done with grade 9s and they haven't done it yet. So I would do simple two-way tables with grade 10s. They're not difficult to do at all. But you've got to know which cells are you using. If you want their hair not tied up, it's this entire row over the total. If you want brown hair not tied up, it's just that cell over the total. And when we get to the next one, from the girls whose hair is tied up, in other words, it's not the whole class, it's just the ones whose hair is tied up. So what I've done in the solutions is I've redone, there's the first question with the numbers filled in. I've redrawn each one next to it so that you can see exactly where I'm taking it. So the hair not tied up is the entire row, 43, out of the total, and simplify. Brown hair not tied up is 20 over the total. Brown or blonde is 100 plus 20 over the total. But 18.3 of those whose hair is tied up, in other words, my sample space, the bottom of my fraction, is 172. How many have black hair? It's 65 over 172. So watch out for, different sample spaces. Okay, question number 19. A tuck shop offers the following choices for lunch. You may either have a sandwich or a pie, and you may either have a juice or a bottle of water. The probability of a person choosing a juice and a sandwich is 0.48. Is the choice of choosing a juice independent of choosing a sandwich? Now, this is not a logical one at all. It's not like tossing a coin and rolling a dice. You don't know if it's independent or not. So you've got to work out with a formula, and this is often where they ask independent events. They'll either ask it just with a formula where you substitute and do manipulation of the equation, or they'll often ask it in a contingency table, a two-way table. But this one is also asked something slightly different, because they say to you the probability of a person choosing a juice and a sandwich is 0.48. So let a juice and sandwich be x. So x out of 250 is 0.48, which means I can solve for x and I can get 120. Now I need to see if they are independent. To see if they are independent, I need to test this formula. Is the probability of juice and sandwich equal to the probability of juice times the probability of sandwich? So let me look first at the probability of juice. So juice is this row, 120 plus 30 over the whole lot, 250, and I simplify. I then take probability of a sandwich because it's juice and sandwich. Probability of a sandwich is this entire column. They gave me the 200. Incidentally, I don't need to work out any of these other numbers. I can, but I don't need to, because what's the probability of a sandwich? It's 200 out of 250. Now, for independent, I multiply these two, so times them together, we get the fraction. I need to see what is the probability of getting juice and sandwich. So this is now my x, which I worked out at 120, out of the whole lot, which is 250. And I get exactly the same fraction, which means choosing a juice and a sandwich, they are independent because that formula works. And I would actually give this reason. And if they're not independent, I would say because this is not equal to that. So the tables are not necessary to draw in your answer, but this layout is important, that they do show probability of juice, probability of sandwich, probability of juice times probability of sandwich, probability of juice and sandwich, conclusion with a reason. So I've shown the tables just so you can see exactly where my totals are coming from.
If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.